Alright, so we're going to look at another problem from section 6.1. So this has to do with initial quantities. So for an example, let's say that water is flowing into a tub at a rate of R of t equals 3t squared plus 4t plus 1, where R of t is measured in gallons per minute. Okay, so first what we want to look at is how do we determine the total amount of water in the tub after 3 minutes if the tub was empty at t equals 0. So to figure out the net quantity of water, all we have to do is take the integral. So the integral. And what is our interval that we're looking at? Well, we're looking at the amount of water we got between 0 and 3. So between 0 and 3. And we're looking at the rate of change is 3t squared plus 4t plus 1. So 3t squared, 4t plus 1, dt. So just like when we were looking at the net displacement, when we were looking at a velocity function, no matter what the rate of change function is, to figure out a quantity, we're going to take the antiderivative and evaluate a definite integral. So what this is going to equal is that's going to be 3t to the third divided by 3 plus 4t squared divided by 2 plus t. We need to evaluate that from 0 to 3. So if you plug those numbers in, what we are going to get is we are going to get 48 total gallons in the tub. Now, let's ask ourselves another question. Let's say that a part B asks the same thing as part A, only when t equals 0, the tub started with 10 gallons of water. Okay, so the rate of change at which water is entering the tub doesn't change. So if between 0 to 3, so that means in that 3-minute span, we have water flowing in at this rate and we have 48 gallons, well, nothing really changes in the rate at which the water is flowing in. The only difference is the amount of water that starts in the tub. So the answer for this would be 48 plus that 10 gallons that we started with, which would give us 58 gallons. So what this does is that it leads us to a general formula. And that general formula, which is the big takeaway, is this. If we want to figure out the quantity that we have at time t, what we need to figure out is the amount that we got between time 0 and time t from our whatever mechanism is giving us something, so whether it's velocity or rate of water into a tub, whatever. So we need to figure out the quantity we got between time 0 and time t, and we also need to add to that q sub naught. What this q sub naught is it's our initial value. Or you can think of that as how much we start with at the starting point. And then this guy right here, this is how much we change between 0 and t. So you can think of this as a change, or an increase, or a decrease.